Today I'm here to look on something very awesome. We have a KVANT laser, and the reason why this laser is pretty awesome, especially for me, is I remember being told once that if I'm going to build some of the best lasers on the planet, I'm going to need to know how some of the best lasers on the planet are made. And here we have definitely a laser that's from an industry-leading brand. It's made in Opavska, Bratislava, Slovakia. So it's definitely not Chinese origin. It's a pretty hefty unit. Puts out 3.9 watts. It's an RGB laser, and the reason why this laser is in today is because it has a fab blue output. So, we're gonna see what's wrong with it. Let's see. They got the LDA cable sent in, and we have the little remote. So, normally this is for like permanent installs and stuff like that, like private use. KVANTs also come with the emergency remote e-stops. Definitely a good thing to have if you're doing laser shows. Let's plug in everything. Key switch. What I like about the key switch is it's off on an angle. It's not very aesthetically pleasing in the off or on position. Yeah, ILDA. Hookup power first, I guess. Yeah, here we go. And let me hook up the deck. We can do input, need input. Alright. Laser window down. You can trust those galvos. Didn't say I had a galvo problem. Laser on. On. Wow, this thing is really quiet. It's super quiet. Laser on. Right, well, it doesn't sound on, but the light's on. So, hearing loss. Everything's quieter now. Enable laser. Yeah. Got output. Do we have blue? I obviously have blue. Oh. It looks a little purpley on camera, but that is just the blue output. Brightness, 25%, 80%. I don't think there's anything wrong with that blue at all. Look at the output here. I think that's blue. Last time I checked, that's blue. Right, well, I guess thanks for watching the video. Now we're gonna get into this, see if there's any problem with any of the wires or connections. So I've run the laser for a few hours now, and it seems like the blue is still working just fine. So I don't think it's a heat-related issue. However, I have found one thing: as the program goes through the cues, the shutter doesn't always operate correctly. So check this out. So you see how the shutter lock closed, open. So the shutter is actually halfway open right now. Closed. Closed. So there it is, partially open again. About 25% obstructing the beam. Closed again. Definitely a problem with the shutter, it looks like. So I'm gonna have to get in there, check out the mechanical action on that, because it doesn't always open. Yeah, interesting. I wonder if it's a bad magnet or counterweight or spring or something in there. Interesting. Only one way to find out, right? All right, are you ready? Am I ready? Are all the screws out? Now we find out. They look all out. They look all out. Oh, that's a good seal. Very good seal. Nice. Got a little earth wire here. So here we have the inside of the top of the lid, and it's pretty cool itself. We have a gigantic desiccant silica gel absorber, moisture absorber, and this will absorb any water moisture that gets into the laser. So say you take it in to a warm, humid venue from a cooler storage or something like that, it would prevent condensation and moisture from building up inside of the laser. And the attention to serviceability in this laser is really good. We have this chart right here, and this chart is actually correlative to the little Allen wrench adjustments on the laser module here itself. You don't even have to open up the laser module to do those adjustments. It's fantastic. You think that's pretty good? It gets better. You'll see here and here little itty bitty white things, and these actually have magnets in them. So what they do is when the lid is on, it does the interlock safety for when the laser is open. Make sure you don't hurt yourself while working on the laser. But the interlocks on the inside of the laser also have these little flip tabs. And these flip tabs have magnets inside of them. So when they're flipped into position, the interlock's defeated and you can work on the laser. Brilliant. I give that a massive thumbs up. Alright, I've been running the KVANT now for a couple of hours with the top off just to see if there would be any problems with the blue modulation. It's not cable related, doesn't seem to be any of the back wires or any of the connections. But the shutter issue also seemed to go away. So you'll notice that even though the shutter moves, it no longer moves into a position where it would obstruct the laser from showing as normal. So what's the main culprit to look for in a situation like this? Well, the one biggest thing that you're changing when you're opening up a laser like this is the amount of airflow inside of the case. It's going to be one of the biggest things to keep in mind. So heat is definitely a cause to look out for. Alright, I found two parts of concern. Firstly, this top component right here, which is an LM2937, a 500 milliamp 5 volt linear regulator. And this component right here, the L2726, which is a dual power supply operational amplifier. So this can handle 28 volts at 1 amp, looks like, according to the data sheet. However, I've also noticed that after I unplug the shutter, it doesn't run so warm. So I'm betting this is what they're using to drive the shutter movement in the front. And there could be a shutter problem with the coils drawing too much power, low continuity, and it could be causing more of a current draw on that operational amplifier. So what I'm going to try to do is I'm going to put a heat sink across these two components, see if that helps fix the problem. As I said, it seems to work better with the case cover off, so hoping that's going to do a little bit to fix this issue. Some changes have been made inside of this laser. Firstly, we got this little heat sink right here. This little heat sink just covers the LM2937, which is not a 5 volt version, it's a 12 volt version. I tested the voltage going in and coming out of that regulator, and it's 16 volts going in and it's 12 volts going out. Now, that's 4 volts across that linear regulator right there, and if it's pushing 500 milliamps, we can easily have 2 watts going through that circuit, which would explain where that heat's coming from. Now, that is also feeding directly into the operational amplifier, the L2726. And I think what ended up happening is that somebody looked at the data sheet and said, this thing can do 1 amp out continuous, and it can take that 28 or split 14-14 power, and so we can get 28 watts out of it. Unfortunately, with linear component, there's maximum power dissipation, a heat factor that goes into that, and that particular component has a 5 watt rating at 75C and a 1 watt rating at 85 degrees. It also has a thermal temperature sensor in there, so it will protect itself if it gets too hot and shut down, which would theoretically explain why the shutter is moving into that area. It would be kicking into the thermal management system and then just powering down the shutter. The other thing that I've also done here is I've checked the coils, and the coils seem to be good. They're both 26 ohms, and they got 7 volts coming out of the operational amplifier. Let's drop in 5 volts on the circuit, and we have, as I said, 52 ohms in total. So that's a 0.13 amp draw, and that's only dropping 5 volts. So realistically, it's not dropping much. I mean, this is a 0.65 watt output or draw. So yeah, that's not too much for the operational amplifier. So I'm assuming that something in here is also taking power from that op amp. Now, anytime you're using a linear component like that, you really do have to watch the maximum current dissipation. I've also put a resistor here, which is about 100 ohms, which has dropped the current consumption from the shutter movement here from 0.13 to 0.04-ish. So it's drawing a lot less current, about 1/3 to 1/2 the current it was drawing before. And the movement works absolutely fine. No problems with that as far as drive current. This, however, did not fix the issue. So I checked the magnet to see how it was acting against the coil, and I think the coil and magnet system were slightly out of phase, and just a little bit of give in the rubber here might have caused that magnetic field to shift one way on the magnet more preferably. So I've also rotated this piece to find a more favorable position between the magnet that's inside and the electromagnetic coils that are driving it. And that does seem to have fixed the issue. I've run this for a continuous day, just about, and no problems. Also, again, no problems with the blue. So I'm hoping that that has fixed all of the problems. I think we can get inside of the laser head here, though, and see what goodies KVANT has done inside of there. I think that will be a very amazing piece of engineering. One less warranty sticker in the universe. Oh, that is a work of art. Alright, so looks like what we have here is we have a knife edge arrangement of 12 red lasers. So these lasers are raised up just a little bit, it looks like about 2 millimeters. And these lasers right here are lower. And it's a pretty similar setup to what's inside of the Citadinis, except for that everything is adjustable from the outside of the laser head. Here we have the 2 laser diodes. One of these is green and one of these is blue. And we have the anamorphic prism pair for the beam corrections. Let's see what this dichro is. Looks to be a reflect blue and a reflect green. So I'm betting that this is green and this is blue. A nice rubber seal, and this whole assembly is on 2 Peltier junctions. So it's all cooled, really nice setup. It's amazing. Let's turn it on. Oh yeah, that is wonderful looking. Let's turn off the light. I'm gonna have to turn down the brightness as way oversaturated. Oh, that's beautiful. That's 12%. That's 60%. Now we're at 100%. Oh, I wish that camera was not making that as hard to see as it is. Let's get a little bit of a better view on that. Back on with the light. That is a lot of incredible engineering that went into that. Take a look at the other side. And we can see all the lasorbs for all of the red lasers in there. That's nice. I got two lasorbs there, one for the green, one for the blue. So those laser diodes are protected. That is an excellent setup. Great job, you guys. Oh, that is excellent. I still think that we have problems with the laser shutter. So in order to figure out a little bit more what's going on, I have two LEDs here. It'll be blue for when the shutter is open, and it'll be red for when the shutter is closed. This will let me know two things. This will let me know if the voltage going to the shutter is the same and operating correctly, and it will also show me if there is a problem, malfunction with the L2627 in there. So the LEDs will power off if there's a problem with that. And I've got a couple of laser cues in which when they change, they'll activate the shutter. So this is a electrical and mechanical stress test, and I'm gonna run it through, see how well it works. So I'm gonna disable cue that's running right now, and we're just gonna run it for a while. And I'm gonna turn off the light, that way we can just watch that LED go back and forth. Oh yeah, it totally looks like something in that shutter mechanism is loosey-goosey. We're gonna have to pull that shutter open and take a look at it. Here's the shutter mechanism pulled out of the laser now. It's a pretty simple construction. We can see here that the shutter arm is just fixed to the rotary actuator simply with this little connector here. It's actually pretty easy to remove. The first thing is to loosen up this little nut here, and then to undo this screw assembly in the front. And you can see it's threaded in there. Now, this is where it gets a little tricky. I had to make my own little press jig, and what it does is it slides in around the outer area. Let's see, get it in there, just like that. Then you can take a longer screw and just put it in there, thread it in. And what I had to do was just put this into a press. I used a vise and just press it out, and it should come out just like that. It's a really awesome design, actually. I thought it was originally just a pressed little lug there, but it's not. So that comes off in two pieces. We have an outer sleeve, and we have an inner little collet, and that collet has a little flange. So when that's pressed in, it compresses against the outer rotor. Pretty cool. Now, the VRAD, which is what this part is actually discontinued. However, the wonderful people at Pangolin managed to make and send me a new one. Because this is a discontinued product, I'm also going to see if I can attempt a repair tutorial segment on this later on in the video, but let's get this new one installed into the laser for the time being. So the first thing I want to do is put this on, put that on, and then I'm going to get this into the vise and just compress it in with this little nut here, and it should squeeze down those two outer flanges and make a good lock on the new rotary actuator. Alright, I've got the shedder all onto the new VRAD right now, and I'm going to be installing it into the laser. So I've also taken out the little mounting bracket that the VRAD sits in, and that is situated in the laser like this. The two countersunk screws go in that way, and I want the shedder mechanism to be in the down position. So what I'm going to do is I'm going to slide that in just like that, loop it over, and just kind of push it through. We'll leave that situated like that for the time being. Yeah, go in. And then we'll just screw it into place with the two screws that hold that into the area. So that'll sit in just like that. Long screw time. Just let that sit there. Jesus grief, what did I put that little screwdriver? Sitting at it. Oh, we've fallen there before. Okay. It's laser surgery time. Be still, my son. Right. Now I'm going to connect up the laser, and we can see which way the plug needs to be plugged into the VRAD, and then I'm going to also seal that up with a little hot glue on each end. But yeah, that should be good. Actually, you know what? I'm going to seal that up before I plug it in. So I've got, so I have in there right now 2 half-watt 32 ohm resistors giving me 64 ohms and 1 watt dissipation. So that should be fine. Those shouldn't warm up at all. Perfect. Let that cool a little bit. And see if I can sneak that onto the back of the VRAD. There's the notch, okay. One goes one of 2 ways. Okay, let's see if that's the right way to go. The new shitter is fully in. I say it's time for another stress test. What do you think? I think so. Let's run it. New plan. We'll just come back to it in a couple of hours. Just put that there for our time keeping measurements, and we'll be good to go. Let's run it for an hour or so. It's gone for a whole hour, and it doesn't look like it has any problems at all. I think it's time to put this laser back together and get it ready to send away. This is a fairly simple part to understand. Much like a galvanometer, there's going to be a few simple components on the inside. There will be a diametrically opposed magnet, and that means that one side of the magnet will be north and one side of the magnet will be south. The other things you'll find are the two electromagnetic coils and the bearing supports on the rotor in the center. And these rotors, apparently there are two of these that meet inside of the magnet, and one of these is slipping. You'll also notice that there are some steel laminate on the outside, and I believe that those are for the magnetic position. So if I were to do this, you'll notice that it snaps into a particular place. And it seems like it loses that home position. It's a really odd problem. I'm not really quite exactly sure what's going on. Now, this is a rather difficult fix, even though it's a fairly simple mechanism to understand. And thus being, there's actually 44 gauge wire in there. And it's a very thin wire. That 62 ohm impedance indicates just how thin it is compared to the 3 to 6 ohm impedance of a galvanometer coil. So that's some mighty hair thin wire. If you notice, the construction is in such a way where they actually feed the wire up from the inside through the PCB and then solder it together. So that makes it a little more difficult to work on. My method of operation is going to be to undo these 4 screws on the outside. And what I want to do is I want to preheat the entire board on the top. So for that, I have some Xbox 360 memory cooling pads from the bottom of the motherboard. And what I'm going to end up doing is I'm going to put one of these on each side of the VRAT. And I am going to lock this in the vise. Now the vise is going to act like a heat sink for this particular operation. And it's going to keep the rest of the VRAD cool while I heat up the PCB. And this is just to protect the magnet from losing any of its magnetic fields. When you heat up a magnet, it can damage the amount of magnetic pull it holds. So that's my thoughts. Preheat it, hit it with the soldering iron, very carefully pull that board up. So let's attempt that. Wow. Okay, that was not what I was expecting in there. No wonder why that's a difficult repair. Hmm. Hey, maybe I can just pull the magnet out. I can. Right. Let's try that. Interesting. That is a tiny little magnet on there. Oh yeah, look at this. I'm gonna give it a light pull and I bet it's gonna slide right off. That's our problem. Yeah, let's get this glued back together and repair. Alright, as you see, I have re-glued the magnet back onto the shaft and it's time to reassemble the VRAD. So the first step is to very carefully reinsert the magnetic assembly inside of the center, and you have to be very cautious of these wires sticking up. The magnetic force is going to want to pull the magnet one way or another. You got to get a really good grip on it while doing this. All right. And now to very carefully solder those wires back in. So I've already cleared out all of the holes in the PCB for where the wires are going to go through. And now I've kind of got to arrange those wires so that they all flow into the holes smoothly. This is going to be the most difficult part of the entire operation. I honestly have no idea how lined that is. That was a pain. That was a difficult job to get all back together. Let's see if the coils are good. We'll test it for continuity across those two sides. 25.7. That looks good. And the other side. 25.8. It looks perfect. Oh, I'm glad to see that. Here's something laser engineers can really appreciate. So I got this little filter right here that I'm going to put over the camera. You can see how cleanly those beams are lined up. You can see each one of those 6 individual reds on that galvo mirror. I got the laser put back together, and the shutter and everything has passed all mechanical stress tests, and it looks like it's operating like new. I've also cleaned up all of the optics. The front window and stuff is a little dirty, and the beam looks amazing. It's a very clean, very nice beam coming out of this laser. It really is absolutely phenomenal. Oh, I could watch that all day. Well, I hope you enjoyed this video, and as always, stay tuned for more. Oh, that's great. Look at that. Love that.